So why they had to put us on a globe and not on a cube or a triangular prism? Why a globe? You know, I mean, hey, the universe could have exploded out of a big bang, put us on a globe. They could have put us on a triangular prism. Hey, you know, really, the laws of physics could have conspired to put us on just about anything. So nothing's really out of the question. There's no reason that a globe is any more preposterous than a flat earth, or any more preposterous than a cube or a triangular prism. But why a globe? Why a globe? Well, here's the thing about a globe is that if they had told us we lived on a cube, it would have posed a serious problem. Because at some point on this cube Earth, you'd be able to go and behold the edge of one of the edges of the cube. You'd be able to go on a trip and behold the corner of the cube. Imagine getting to one of the edges of the cube and there's a very sharp and pronounced corner, edge, that if you traverse to the other side, you're now on the other plane, and you know it's probably gravity that keeps it all in place or whatever. You can concoct any theories you want. But that's a problem, isn't it? Because, you know, there's 6 sides to a cube, and you know, you got all these corners and all these edges. Those would be very easy landmarks to spot. And people would be able to go and falsify or prove that we in fact live on a cube Earth. It'd be very easy to do it. Unless they had an Antarctic treaty for the cube and every single corner and edge was blocked off because for science and for the penguins, which is essentially what the Antarctic treaty stated purpose is, to protect science and penguins. Yeah, right. If they told us we lived on a cube, that'd be a really tough one to sell, because you can go and find that very distinct corner edge before you get onto the next side of the cube Earth. And if you think that sounds preposterous, well, don't worry, because we have gravity, and gravity is the reason you don't fall off the side of a cube, because it sticks you in place. Cube Earth makes perfect sense. Just add enough gravity, maybe a little bit of axial tilt, maybe a little bit of equatorial bulge, you know, and you know, you got yourself a working model. You just got to tweak it enough to match our observations, and you're good. But a globe is conveniently way harder to falsify, because on a globe you have this perfectly ever sloping smooth surface, constantly curving at just the perfect rate where it eventually loops back on itself in what we call a circle shape or a sphere. And if the globe is just big enough, then it will look flat locally. If the globe is just big enough, it will look flat on a local scale. You know, when you look out at the ocean, or according to Neil deGrasse Tyson, even if you're on some type of plane at 128,000 feet, according to Neil deGrasse Tyson, you wouldn't even see the curve.
That stuff is flat.
I travel a lot and I fly a lot, and I can see the curvature when I fly.
Okay, so 35,000 feet, you can see it, right? That's what you're saying?
Generally speaking, I can see a slight curve to it, yeah.
Okay, so Neil deGrasse Tyson says that you can't see it at that altitude, so I really...
This really doesn't... We have satellites.
That stuff is flat.
It still looked flat from 128,000 feet high. So if the globe is big enough, you can get away with saying that it's actually flat on a local level, the way we all see and experience it. And you wouldn't have to worry about any pesky corners or sharp edges the way you have on a cube Earth or a triangular prism Earth. The globe is perfectly unfalsifiable. The globe is perfectly unfalsifiable. It's just a perfect shape that locally, no matter where you are at any point, even at 128,000 feet altitude, according to Neil deGrasse Tyson, it will look flat. But on cube Earth, or triangular prism Earth, or rectangular prism Earth, you run into a problem. With this six-sided cube Earth, you have all these corners, you have all these sharp edges. You don't have a gradual, just conveniently unfalsifiable curvature that looks flat locally, but is technically a curve, as they claim. On cube Earth, people would go on vacations. You know, instead of going on vacation to the Grand Canyon and witness the marvel of the Grand Canyon, on cube Earth, people would go on vacations to one of the corners, to one of the edges, and it'd be this big, you know, guided tourist event, and you'd step, you know, you'd brace yourself, you'd be right there on the edge, this very definitive, easy to distinguish, easy to falsify, undeniable edge. You don't have to be at 128,000 feet like Neil deGrasse Tyson says. You don't have to be that high on cube Earth to see the obvious corner that you're about to step over. So on cube Earth, you'd go on a guided tour and you'd brace yourself as you step from one side of the cube to the other, and the magic of gravity keeps you stuck to the side of the cube, keeps you from falling off on cube Earth. But the globe is perfectly, conveniently unfalsifiable. The globe can locally look flat if you're just enough of a speck of dust on its surface that it'll look flat locally, and you won't have to worry about any pesky, easy to distinguish landmarks on the geographical surface of the globe that could give away that it may not be a globe. Cube Earth, globe Earth. And you know, you could maybe say, well, but on a flat Earth there should be an edge. That should be easy to falsify, right? Well, the Antarctic Treaty makes it very suspicious, very bizarre and suspicious things going on with the South Pole. I'm not going to get into it now. You should know by now. So that's why they had to put us on a globe, because the globe is perfectly unfalsifiable. It's just gradual enough a shape that it could pass as flat, but it could also pass as sphere because it's so gradual. Cube Earth can't put us on a cube, can't put us on a triangular prism, wouldn't work. On a globe, just enough, to quote Neil deGrasse Tyson, wiggle room.
I travel a lot and I fly a lot, and I can see the curvature when I fly.
Okay, so 35,000 feet, you can see it, right? That's what you're saying?
Generally speaking, I can see a slight curve to it, yeah.
Okay, so Neil deGrasse Tyson says that you can't see it at that altitude, so I really...
This really doesn't matter. We have satellites.
That stuff is flat.